Higher level paper 1, question 12. Now we're being asked to show that two things are skew lines. We could do that graphically if we want. We could change the view from a graph page to be 3D graphing. And we're going to change it so we can type in the equation of a line by pressing menu and changing the graph entry edit type to parametric. And we're going to see if we can type in what we think to be the parametric equation for the first line, which I've called L1. So I'm saying it's 1 plus 1 lot of lambda, or I'm going to use the parameter t here. I got 0 plus 3t, and I've got 4 minus 5t. And I've had to set up the value of t to be something sensible. Let's go from -10 to 10 to give us hopefully something on view in our window. If I click OK, click back into one of the boxes and press enter, there is the skew line. If I press the letter A, I can animate it around, and there is indeed one of the lines. I'll press escape and press O to return it back to the origin view. Now I'm just going to pull up the opportunity to type in the second Cartesian line, which we've called L2. I can use the same parameter here, the things are independent, or I can use a different one. I'll just stick with the same one, shouldn't be a problem. So the first parameter would be 1 plus 3t. Oops. Then we need to go to the second box, which is -2 plus t. And the third one is 1 minus 2t. And the parameter t has already been defined, and we get a second line there. And you can see that these two lines are skew in space. They're not going to intersect at any point, and therefore we should be able to do some algebraic manipulation to prove that. We can use the calculator page to help us. If I just insert a calculator page and do menu, algebra, solve system of linear equations, I'm going to see if I can solve a system of 3 equations, but the parameters I'm going to use, I'm going to use 2 parameters for my line. I'm going to use lambda and mu, L and M. And so what I'm going to type in is the 3 statements for the x coordinates, the y coordinates, and the z coordinates. So for the first one, it'll be 1 plus 1 lambda will be equal to something. 0 plus 3 lambda will be equal to something. I'll fill these in a minute. And 4 minus 5 lambda will be equal to something. For line 2, I'm going to say that's 1 plus 3 mu. You'll recognize these from what we just typed in a moment ago. -2 plus mu. Oops. M for mu. And 1 minus 2m. Now, if these lines are skew lines and I press enter, there should not be a solution for L and M that satisfies all 3 equations all at once. And lo and behold, that's confirmed. If I had just 2 of the equations, there would be a solution, but they would give different values for L and M if I solved different pairs of equations. So that's part A and part B. Now we're after the plane, and we're going to have to use the direction vectors of L1 and L2. We're going to have to work out a line that's normal to them, so we'll do the cross product. So if I do menu and go down to matrix and vector, and what I want to do is go to the very bottom of this for vector, and I want to do the cross product. I want to do the cross product to 2 vectors, so I'll just press the template button to get the vector template. And the first one is going to be a direction vector of line L1, so it's going to be 1, 3. And to get a third row, if I press the carriage return button, which is bottom right hand corner of the keypad, just to the right of the letter U, and I'll type in -5 there. I'll put a comma, pull up another vector, paste it in, and the direction vector here is going to be 3, 1, and again carriage return -2. When I do the cross product, that's my direction vector, -1, -13, -8, and that can lead me on to working out the equation of the plane. When we get a view of that plane, we can go back to the diagram which has our skew lines. We'll have to change the menu back to function view, and what I'm going to do is set up a fraction template. The equation of my plane is x plus 13y plus 8z is equal to -3. So I can do -3, subtract off x, subtract off 13y, and divide it all by 8. When I press enter, I get a plane, and when I rotate it around, you can see that that plane is indeed parallel to both lines L1 and L2 as they spin round. You can have a look at it there. We've been given a line 3. It looks as if we're going to have to work out line 3 and plane pi 2, but we're going to have much greater difficulty there because it's got values of k and it's going to involve us doing algebraic manipulations. So we will leave it there. Question is done.